All right, guys, one of my favorite topics today, mathematics and finance. I love this stuff. Not that I have tons of finance, but I like talking about it, like studying it, and have benefited some, so it's a good topic. A few words here you kind of need to know. First word is annuity, and that's what a lot of what we're going to do today is about. Annuity is a sum of money that's paid in regular equal payments. So if you own an annuity, they will pay you in regular equal payments, for the rest of your life or whatever. The amount of an annuity is the sum of all the payments from the time the first payment's made until the last payment's made, coupled with the interest. So three things for the amount of annuity. All the payments altogether, including the interest. Okay, now here's the amount. Here's how you can tell how much an annuity is worth. The amount of an annuity consisting of N is our number of payments of size R. That's how much you are getting paid each time. I is the interest rate per time period, and there's our formula. Okay, so that's how we're going to roll with the annuities and how much the thing is actually worth. Because sometimes you can sell your annuity and not take the payment. So let's see what we got here. All right, see, it says an investor deposits $400 every December 15th and June 15th for 10 years. So 2 payments a year for 10 years. In an account that earns an interest rate at 8% per year, but compounded semi-annually. That's important. How much will the account immediately after the last payment, how much will it be worth? So let's go back to that formula we just saw. The R, and then we had that fraction bar, and we had 1 plus I to the n power minus 1 over I. Okay, that's going to tell us the value. Let's go through what this stuff meant again. The R is the amount that they're investing, which is $400. All right. And here's 1 plus the interest rate, which is 0.04. You could just write 1.04 right there. N is how many times they are depositing it, which is there's 20 payments they're making, minus 1 out here, and down here is I again. So be very careful and punch all that in the calc. Okay, you got to be really careful when you punch it in. A lot of parentheses there. And I'm getting this 11,000. Let me fix that real quick. 11,911 and 23 cents. And you might want to practice punching that in your calculator. I told you that before. Make sure there's a lot of parentheses to punch that in. Okay, how much money should be invested every month at 12% per year, compounded monthly? There's our rate. In order to have $4,000 in 18 months. Now, every month, so that means they're making 12 payments per month. Now, watch how we set this up. It's going to equal 4,000. That's the final amount. What we don't know is how much to put in. So we don't know what R is. When I set my fraction up, I'm going to have 1 plus 0.01 because the interest rate is 12%, but it's every month. So you're dividing the 12% by 12, which gives you 1%. So that 0.01 came because I did 12% divided by 12%. And then minus 1 out here and put the same n down here. So we have to solve for R. So what I'm going to do is I'm going to punch in my calculator, this whole fraction, right, and divide it into 4,000 to see what my R is. So I'm going to take a second, punch that in. All right, and what I get is $203.93. Okay, and all I did there on my calc, and you may want to do this, I put this whole thing in my calculator, got that value, and did 4,000 divided by that value to give me that number. All right, the present value of annuity. Now, we just got finished doing an annuity, like what it's worth at the end of the time. Sorry, I had a little water there. And now we're going to talk about what it's worth at any given moment. So the present value of an existing of N regular payments, so that stands for the same thing, of size R, that's the amount they're paying. Interest rate is I per time period is given by this formula. A little bit different, okay, so make sure you get that down. And all this stuff pretty much stands for the same thing. All the letters do. So let's try one of these. A person wins $10 million in the California. That's a good person right there. And the amount is paid in yearly installments of $500,000 a year for 20 years. What is the present value of his winnings? Assume that he can earn 10% interest compounded annually. So that's only one time a year. All right, let's set this up again. The formula: R, big fraction bar, 1 minus 1 plus I to the negative n power over I. Okay, so that's the formula for present value. Okay, so here's what we know. We know R is 500,000. That's what he's getting each payment is half a million dollars. Set up my big fraction bar. 1 minus 1 plus I. Now, I is always a tricky thing. You got to figure out what the I is. He's getting 10% interest, and you got to divide that how many times it's compounded. This is compounded annually, which is just one time a year. So we can just put the 0.1. That's actually, 10%. And then my exponent is negative n. N is how many years? This is 20 years. And over the I again, which is just 0.1. So again, I'm going to take all that time, punch all that in my calculator. And this guy's in really good shape right here. He is worth $4,256,781.86. And again, that is what the present value is pretty much as soon as he wins that thing. So, yeah, pretty good. Okay, the next one's installment buying. Basically, this is repayment of a loan. Okay, so like if a loan A is to be repaid in N, so N is how many payments you're going to make. Interest rate's I still. The size R is how much each payment's going to be, is given by this formula. Okay, now the A right there, remember, is the amount of the loan. How much did you borrow times the interest rate, and then the denominator is going to have that again. So let's look at one of these. All right, last one here. A couple borrows 10%. So, golly, a couple borrows $100,000 at 9% interest as a mortgage loan in a house. They expect to make monthly payments for 30 years. That's a long time to repay the loan. What's the size of each payment? Okay, so we know our formula is going to be RI, total amount, 1 minus, this is the same formula on the last slide. Okay, and that is to give us what the payment's going to be. Okay, so let's set that up right here. Don't know R, that's what we're trying to find out. I is the interest rate. It says the interest rate is 9%, and they're going to make that every single month. So I'm doing the 9% divided by 12 to figure out what that rate is, and I'm getting 0.0075. So I got 0.0075 times the amount of the loan, which was $100,000. And then I got 1 minus on the bottom, 1 plus 0.0075 to the negative n power. N is how many payments they're going to make. If they're going to borrow for 30 years and make a payment every month, because that's 360 payments. That's a lot, negative 360 right there. So I'm going to punch all that in the calculator really quickly. And the payments are going to be $804.62. Okay, now, one word about this lesson and what we're going to be doing tomorrow. These formulas are huge. Please write them down today before you come into class tomorrow. The key is going to be figuring out which one we're using for what, like what kind of problem is it, and we'll be golden once we start getting into some of this. You won't have any trouble doing that. The one challenge may be the calculator. Please make sure you bring it with you, obviously, but also it would not be a bad idea on this video to go back to a couple of these slides and make sure you can plug that stuff in your calc successfully, because it's going to be a challenge a little bit, even using the calculator. All right, look forward to seeing you. See you tomorrow.